In this example, we will find the eigenvalues and eigenvectors of the matrix A equals 5, -2, -1, 4. To start, we'll find eigenvalues as solutions to the characteristic equation, which is given by 0 equals the determinant of A minus lambda I, which is 5 minus lambda, -2, -1, 4 minus lambda. Computing the product of the diagonal minus the product of the off diagonal, we'll have 5 minus lambda times 4 minus lambda minus -2 times -1. And distributing this, we'll get lambda squared minus 9 lambda plus 18. Now we can factor this quadratic as lambda minus 3 times lambda minus 6. And since we want it equal to 0, we get that our eigenvalues are lambda 1 equals 3 and lambda 2 equals 6. Now that we have found our eigenvalues, we need to compute an eigenvector for each one of them. Let's start with lambda 1 equals 3. Since it is an eigenvalue, there's an eigenvector we'll call v1 with unknown entries a and b that satisfies a times v equals lambda times v. In other words, 5, -2, -1, 4 times our vector AB is equal to the eigenvalue 3 times AB. On the right-hand side, we can simply multiply each entry by 3 and get the vector 3A, 3B. On the left, we'll need to multiply the matrix onto the vector. So in the first entry, we'll have 5 times A plus -2 times B, or 5A minus 2B. And in the second entry, we'll have -1 times A plus 4 times B. So now we need these two vectors to be equal. 5A minus 2B, -1A plus 4B has to be equal to 3A, 3B. Since these vectors are equal, the top entries must be equal. That is, 5A minus 2B has to be equal to 3A. And using this, we get a relationship between A and B. From 5A minus 2B equals 3A, we can subtract 5A from both sides and divide by -2 to get that A must be equal to B. It's worth mentioning that the eigenvectors come in infinite families. Any vector where A equals B other than the 0 vector will be an eigenvector with eigenvalue 3. Because of this property of eigenvectors, if we had looked at the second entry, -A plus 4B equals 3B, we would have found the same relationship that A is equal to B. So we only need to look at one of the entries, either the top or the bottom. Here, we compared the top entries. Since we know that A is equal to B, we can pick any value of A and any value of B so long as they're equal. To keep it simple, we'll pick A equals 1 and B equals 1, giving the eigenvector 1, 1 for the eigenvalue 3. Now that we've found the eigenvector for the eigenvalue 3, we'll move on and find the eigenvector for the eigenvalue 6. Again, we'll write this vector as A, B. And we have that our matrix A, 5, -2, -1, 4, times AB is equal to 6 times AB. And on the right-hand side, we'll have 6 times A and 6 times B. While on the left, we'll get the same matrix multiplication onto the vector AB. So again, we'll have 5A minus 2B over -A plus 4B. And again, we can find a relationship between A and B by comparing the top entries. 5A minus 2B is equal to 6A. And from this relationship, we can subtract 5A from both sides to find that A must be equal to -2B. So we need to pick values of A and B that satisfy this condition. Picking B to be 1 will get that A is -2. So an eigenvector for the eigenvalue 6 is -2, 1. So we can conclude that the matrix A equal to 5, -2, -1, 4 has the eigenvalue 3 with eigenvector 1, 1, and the eigenvalue 6 with the vector -2, 1.